And welcome back, students, to our next lesson with the LC3. We're delving now into the ISA, or if you remember, the instructional set architecture. So here's our instruction set architecture. If you recall, the ISA is all the programmer visible components and operations of the computer. So this is things like memory organization, so your address space, how many locations can they be addressed? Addressability, how many bits, is it 8, is it 16, is it 32, are assigned per location. Register sets, how many are there? What size are they? How are they used? So all these different things. All right, and of course, lastly, the actual instruction sets themselves, which are comprised of opcodes, data types, and addressing modes. Now, the ISA provides all information needed for someone that wants to write a program in machine language or translate it from a high-level language such as C++, C#, Java to machine language. All right, let's do a quick overview of the LC3 when we're going to talk about memory and registers. Memory is an address space. There's 216 locations available in memory, or 16-bit addresses. So for those 216 locations, there's 16-bit addresses. In terms of addressability, 16 bits. We've kind of already discussed that it has a 16-bit architecture. All right, now when we talk about registers, these are temporary storage. So a good way to think about this is like the RAM that's in your computer. It's kind of like a temporary storage. In fact, RAM has its own kind of built-in functions similar to this. All right. Temporary storage accessed in a single machine cycle. Accessing memory generally takes longer than a single cycle. There's 8 general purpose registers, R0 to R7. Each of those registers is 16 bits wide. So you might have to wonder, how many bits is there to uniquely identify a register? Well, if you have 7 bits, you're going up to R0 to R7, that's 8 bits, or not 8 bits, but 8 digits that you have to represent. You can probably figure out how many bits that would need to be. And of course, there's other registers which are not directly addressable, but are used by and are affected by instructions. There's also the PC, or the program counter, and condition codes. Okay. Let's continue talking about instruction sets. All right, there are opcodes, a total of 15 different ones. All right, there's the operate instructions, and, add, and not, which we will look at today. You have data movement instructions, LD, LDI, LDR, LEA, ST, STR, and STI. So those are pretty much all your load and store kind of instructions. You have control instructions, BR, JSR, or JSRR, JMP, which I think we discussed before as jump, RTI, and trap. And lastly, there's some opcodes which set or clear condition codes based upon the result. So N is negative, Z is 0, and P is positive, or anything that's greater than 0. In terms of data types, we're going to be using 16-bit 2's complement integers. And when we're looking at addressing modes, how is the location of an operand specified? Well, typically there's non-memory addresses, which means there's immediate and register. And then there's also memory addresses, which are PC relative, so program counter relative, indirect, and then also base plus offset. And we've kind of seen some of this when we've looked at some of those different things before, but we'll really start delving into it in full depth now. All right, let's get into our operate instructions. There are only 3 operations in the LC3. There's the AND, add, and not. Now, the source and destination operands are registers. So you're never going to reference memory. These instructions don't use that. In fact, they're only ever going to use registers because it's meant to be a temporary operation. Now, and can use immediate mode, where one operand is hardwired into the instruction. So you can actually have hardwire a code into the program that you want it to do. Now, on each of these pages that we're going to go over, there's also a data flow diagram, which each instruction, which kind of illustrates when and where data moves in order to accomplish the desired operation. So let's look first at not. With the not register, you can see in here, I have my opcode right here at the front, 1001. We have our destination, and we have our source, and then of course this is just the rest of our file here. So source and destination nodes can be the same register. So you could pull from that register and say, hey, I just want to flip the values of that register. So let's just say the value in R0. I'm just going to condense it down. I'm not going to do a full 16-bit. But let's just say for our purposes here was 101. Well, with that NOT operation, as you recall, it flips those bits, so it becomes 010. Right? And it's just going to store it back into that same place that it came from. Right? If you're looking at the diagram here, right, you have things coming into the destination file. Here's your source file going through the ALU. So the source file goes down to the ALU, and then it comes up, goes down, back into the source file. Now with the add or and register, right, you can see in here, add is opcode 0001, and is 0101. All right, again, destination in source 1 and source 2. This 0 right here means register mode. So notice you only have these two zeros right here. Those don't really have anything to hold. These two values right here, though, means it's a register mode. So it's not going to be pulling anything from memory. So if we look at our diagram, you can see we have source 1, right, and source 2, both feeding down into the ALU. So pretty much we're adding those two values in source 1 and source 2. Right, and then it's following this trail here, and it's going to store back up into the destination. Now, it's very likely that you could store it in somewhere else, but often you're not going to store it back into one of those two. You can, but not often. Usually you're going to store it in a different register. Now, there is an and that's immediate, and if you notice that what's changed now is that you now have a 1 here, and in that, the immediate field is now sign extended. Right, so you have your instruction register here, and it's now bringing this command in. And then you also have a source code right here. And then, of course, this part is still the same where it goes out into your destination register. Now, using operate instructions. With only add, how do we subtract? Right, because obviously add is not a subtract operation. So how you do this is typically, let's say you want to store your value in R3. So we know that R3 would be equal to register 1 minus register 2. You're going to subtract whatever the value in register 1 is with register 2's value. So what we do instead is take the 2's complement of register 2 and then add that to register 1. So how we can do that is we say R2 is equal to not of R2. So we're flipping all those bits. Then we say that R2 is equal to R2 plus 1. Then we say R3 is now equal to R1 plus R2. Continuing on to the next operation, if we're looking at AND, we have to ask how do we use OR, right? And very similar, we have to do a couple extra steps if we want to do an OR operation. So with an OR, I have, in this case, I have register 3 and I want to do an OR of R1 and R2. So what we're going to do is De Morgan's law here. We're going to invert R1, R2, and then results. So we start off by first saying that R1 is equal to not of R1. R2 is equal to the not of R2. R3 now is equal to R1 and R2. So notice we're doing an AND operation. Then we'd say R3 is now equal to the not of R3. So notice we're storing it back into R3. Right? Now, how do we copy instruction from one register to another? So let's say I have the value in R3 and want it to go to R2. Well, it's pretty easy to do. Right? All I do is I'm going to say R3 is equal to R2 plus 0. And what that plus 0 does is it makes an add immediate. And similarly, if I want to initialize a register to 0, so pretty much I want to clear out any value that's in it, I'm going to say, so for example, I have R1, I want to make it 0. All I do is say R1 and 0. Again, when you put a 0 there, that makes it immediate, and it's going to clear out all your values there and make them into 0. And that concludes this lesson for today, folks. Until next time.